2004, when NASA's Cassini probe visited Saturn, it found some pretty good evidence to support that idea.
If you went to Titan and you were looking at the landscape, you would see something that in some ways would look almost familiar to you. You might see big mountains and valleys that were carved out by running liquids.
In fact, as Cassini flew past hazy Titan, its radar read the surface below. Scientists saw channels cutting across the surface, much like rivers on Earth do. Some as long as 900 miles. The first strong evidence of liquid on Titan.
There are large bodies of liquid on the surface of Titan. Nowhere else in the solar system except for the Earth are there any large bodies of liquid.
Could water, the liquid that carves Earth's mountains and valleys, also be carving these features on Titan's surface? Or could it be something else? The problem is that Titan is too far away from the sun. If it was water, it would be frozen solid.
It's about -300 Fahrenheit on Titan, so things behave very differently on Titan than on Earth. Because it's so cold, methane, which is a gas on Earth, is a liquid on Titan.
One mystery solved. But just because methane is a liquid on Titan's surface doesn't mean it's part of a weather cycle like water on Earth. So how do we know that this methane also falls from Titan's sky? That answer is shrouded in mystery. Literally.
Titan is completely covered in a thick haze of smog particles. Like a very, very bad day in Los Angeles.
Despite the haze, the Cassini probe once again revealed the answer.
We can see the upper clouds, and we can see evidence for rainfall because the clouds drop very precipitously. We hypothesize that we're seeing the effects of rainfall.
Methane rainfall.
We think that Titan has methane monsoons, so we think that sometimes Titan has a lot of rain that is able to carve rivers and leave large fluvial deposits on the surface.
Cassini's radar imaging also revealed large methane seas on Titan's surface.
If you have liquid methane on the surface in a lake, for example, that methane can evaporate off and become methane gas in the atmosphere. So you have kind of a cycling of methane between liquid phase and gaseous phase and between the surface and the atmosphere that's very similar to the water cycle that occurs on the Earth.
But methane is a flammable gas. So why isn't Titan on fire?
For any combustion, you need two things. You need both a fuel, which methane is, but you also need oxygen. And on Titan, you lack the oxygen. So the whole thing is basically a big fuel canister, but there's no oxygen with which to burn it, and so it's all very stable.
If it were cold enough here on Earth to produce methane rain, the oxygen in our atmosphere would create a worldwide firestorm. Luckily for us, that can't happen. Titan's methane cycle makes it both alien and familiar to us.
To me, Titan is very exciting because all the materials are so different, and yet these processes produce very similar landscapes to what we see on Earth.
Titan proves that where alien weather is concerned, looks can be deceiving. On Jupiter, it's all about size. Drop the Great Red Spot onto our world, and it makes even our worst hurricanes look like a breeze. This is the biggest and oldest storm in the solar system. And Jupiter's most famous feature. It even has its own name, the Great Red Spot.
It's about 2 or 3 times the size of the Earth, which makes it the mother of all storms.
We've known about the Great Red Spot in Jupiter's southern hemisphere for more than 300 years.
When
when Galileo invented the telescope, within a few tens of years, people had seen the Great Red Spot, and it's still there.
Familiar yet mysterious. Nobody knows how the Great Red Spot formed. But scientists are finally probing below Jupiter's cloud tops to uncover more about this enormous alien storm. The storm is powerful. With wind speeds of 300 miles per hour, it rises miles above the surrounding clouds. On Earth, we have storms that seem similar, though smaller and milder. Hurricanes. Also known as cyclones or typhoons, depending on where they form. They're our most destructive weather systems. But is there more than just a passing resemblance between Earth's cyclones and Jupiter's red spot?
When you look at the Earth from space at a hurricane, it's this big swirling pattern. It's round, it rotates. Jupiter's big storms look big and round and cloudy, and they rotate. But there the similarity ends.
In a hurricane, there is an internal core, which is called the eye of the tropical cyclone. And that's a region of very calm winds and no clouds. And usually has a size of about 10, 20 kilometers in diameter. And then away from the eye, there is the eye wall. Those are really cloudy regions with a lot of rain. And as you move outward, there is a whole region of about a couple of hundred kilometers with very, very strong winds and very strong rain.
Hurricanes draw power from heat in our oceans. But Jupiter has no oceans, and the sun isn't close enough to power a storm as big as the Great Red Spot. So where does it get its strength? Part of the answer is Jupiter's size. It's the largest planet in the solar system, almost as big as all the other planets combined. This mass generates a very strong gravitational pull, which in turn creates interior heat that rises to the surface. Another piece of the puzzle may be Jupiter's hypersonic rotation. Despite being much larger than Earth, Jupiter's day lasts only 10 hours. In other words, it spins incredibly fast. Could energy from this dizzying spin feed the Great Red Spot?
The weather is really dominated by this fast spin. There's shearing between different latitudes, and that shearing, plus a lot of heat that comes up from the interior of this very massive object, 290 times the mass of the Earth, leads to very violent storms.
Both Jupiter's and Earth's storms spin around in a familiar spiral shape. On Earth, it's because of an effect called the Coriolis force.
I'm sitting at the North Pole, and I want to throw a ball down to a friend who's in Los Angeles. And so if I threw the ball in that direction, the Earth rotates, and the ball will end up in the middle of the Pacific rather than in Los Angeles. So it's like if the trajectory was deflected to its right. And that's what we call the Coriolis force.
This force spins storms clockwise in our southern hemisphere. But there is a stark difference between Earth and Jupiter. The Great Red Spot is in Jupiter's southern hemisphere, and yet it spins counterclockwise. This is because of some other powerful winds.
It's bounded by jets, which are moving in opposite directions. And so like a cog between two conveyor belts, they're just feeding energy and momentum into the system.
Jupiter's complex jet streams spin the storm into organized chaos. But the greatest difference between Jupiter's red spot and our storms may be Earth's solid surface. Once a hurricane hits land, it comes apart pretty fast.
Where they come over land or over mountains, their behavior is very different from where they form over the oceans and over warm oceans in particular, where we get hurricanes. And on Jupiter, there's obviously no solid surface.
With no land mass to stop it, the Great Red Spot just keeps on spinning and spinning and spinning. Scientists hope to learn more about our weather by continuing to study the storm.
On Earth, there's a limit to how far ahead you can predict the weather. On Jupiter, we can forecast where the red spot is going to be months in advance. It's practical value to understand what makes weather on Earth so unpredictable, and aspects of the weather on Jupiter are much more predictable.
Unpredictable or not, Earth's weather never gets as violent as on Jupiter. That's lucky for us, because if we shrank the Great Red Spot down to fit on Earth, we'd be in for disaster.
On the Earth, we go up to Category 5 hurricanes, nothing but Category 10 hurricane here. Not much would be left.
Alien storms are vastly different everywhere you go in our solar system. Even our next-door neighbor, Venus. They say we're sister planets. Lucky the resemblance doesn't include weather. Otherwise, we'd get seriously burned. Venus may be our nearest neighbor, but somehow its weather is radically different from ours. The second planet from the sun is a cross between a toxic waste dump and Death Valley, but even worse.
So it's almost a planetary definition of hell.
The temperature is 900 degrees Fahrenheit. The pressure on the surface is the same as half a mile below the Earth's ocean. And if that's not enough, the upper atmosphere of Venus is choked with sulfuric acid clouds and winds clocked at 250 miles an hour.
To get a comparison for Venus, the best thing to do is climb inside of your oven and crank it up. And then in terms of pressure, you're talking about deep sea diving. It's like nothing. There's nothing comparable on the Earth. It's just a very, very extreme object.
On Venus, there's just no escaping the heat.
If you built up a hot spot on Venus, the massive atmosphere would just carry that heat away and spread it around.
But Venus shines so brightly in the night sky because its thick clouds reflect almost all the sunlight it receives. In fact, some early scientists assumed Venus would have moderate Earth-like temperatures.
When we went by Venus in 1962 with a spacecraft, we thought we would find a surface at 90 degrees Fahrenheit, sort of like Miami, Florida.
We were dead wrong. Something else must be at work on Venus. But what? So why doesn't Venus cool off the same way Earth does?
On the Earth, for example, we have sunlight coming in, hitting the surface of the Earth. Earth warms up a little bit, but the oxygen and the nitrogen in the atmosphere don't impede the light. So when it gets released out in the infrared, it goes right through the atmosphere and leaves and goes into space.
But on Venus, the atmosphere is 97% carbon dioxide, giving a whole new meaning to the greenhouse effect.
It becomes very, very hard for the surface to get its energy out.
So Venus really taught us a lesson that if you have a blanketing gas, a greenhouse gas, it can warm up the atmosphere tremendously.
But why does Venus have so much more CO2 in its atmosphere than Earth? The two have much in common. They're even called sister planets. They're almost the same size, have roughly the same amount of carbon, and billions of years ago, both had lots of water. But eons ago, their paths mysteriously diverged. On Earth, water fostered life.
The Earth has most of its carbon in life forms, in the trees and the animals. But if you took all that carbon that's in the near surface rocks and burned it up or released it, you would then create an atmosphere very much like Venus.
Venus's close proximity to the sun made it too hot to sustain liquid water. Instead, its water evaporated into the atmosphere, trapping the heat deposited by the sun and creating a runaway greenhouse effect. Once in the atmosphere, the water molecules were exposed to solar ultraviolet rays that broke the molecules apart.
It really wasn't recognized by the scientific community how important the greenhouse effect was prior to going by Venus and seeing this amazing place where it was 900 degrees Fahrenheit, not 90.
It took several doomed missions to Venus to figure it out. Starting in the 1960s, both the United States and the Soviet Union sent unmanned probes past the planet and down to its surface. It didn't take long before Venus crushed and burned them. Then, in 1981, the Soviet lander Venera 13 set a record for survival on the surface of Venus. 2 hours and 7 minutes. It was able to take pictures and samples of the surface before being overcome by the heat.
You're sitting there with this 900 degrees Fahrenheit heat all around you. It's going to get in there and bake you after a while.
Scientists one day hope to send a probe to Venus that can survive its hellish environment, to help us confirm our theory of how this planet went astray. Because if circumstances were just a little different, our sister planet might just be our twin. Remove our atmospheric shield, and you're on the road to hell.
As soon as you're heated up to something like 400 degrees or so, you probably start getting some smoldering smoke, and way before it gets to 900 degrees, the Earth would burst into flames because all the oxygen around.
Once the oceans boiled away, the carbon locked in rocks on the ocean floor would cook, and over millions of years re-enter the atmosphere.
Probably if you came back to the Earth system after this happened, you'd find a planet looking much like Venus.
We're a long ways away from such a drastic change, but it's sobering to look at Earth's sister planet when the sister planet went on a very different track than we did.
So cosmic forces turned Venus into a planetary barbecue. But on this violent, stormy world, time and the elements have produced some of the strongest thunderstorms ever measured. Welcome to Saturn. Lightning cuts the sky. This violent weather system grows bigger than the entire United States as it pummels the atmosphere with the most powerful lightning ever seen. Except this lightning can't be seen, because these bolts are electrifying the skies over Saturn. Despite the raw power of Saturn's lightning, scientists have been unable to see it, partly because Saturn's rings are too bright.
The rings are so bright, if you were on the night side of Saturn, it would be considerably brighter than the Earth under a full moon.
But Saturn also hides its lightning within thick, choking clouds of ammonia.
It's probably 100 kilometers down that the lightning is happening, and that complicates seeing the lightning flashes.
But the lightning is there, and scientists know it because they've heard it. Radio wave detectors on the Cassini orbiter have recorded the sound of Saturn's lightning.
We can hear the static of lightning just as you could with an AM radio going down the highway on Earth.
And this static reveals the power of the lightning that we can't see.
You can measure the energy in those radio waves and compare it with the energy that your radio picks up when there's a thunderstorm around on Earth. And the Saturn ones are big. They're more powerful, maybe 100 times.
And Earth's lightning can help scientists understand how storms work on Saturn. Within Earth's storm clouds, just like in Saturn's, updrafts drive moisture higher, causing ice to form. These ice crystals rub against each other, take on a positive charge, and become attracted to negatively charged water droplets lower in the cloud. This sets the stage for a potentially powerful discharge of energy.
Once you get that charge separation that builds up so intensely, that some theorize that it can be as strong as 100 million volts, that the cloud then must release that energy.
On Saturn, the same thing happens on a much larger scale. In fact, the lightning is 100 times stronger than Earth's. That's a staggering 10 billion volts of electricity. Thunderstorms in Saturn's southern hemisphere span thousands of miles and can last as long as a month. But scientists aren't sure what makes Saturn's storms bigger and longer lasting. It could be Saturn's supersaturated atmosphere.
Probably the fact that there's more water in the atmosphere, pound for pound, on Saturn makes the storms bigger.
More water droplets means more friction, which means bigger lightning bolts. But energy emerging from the planet may also contribute to the power in Saturn's thunderstorms.
It turns out that where Lightning Alley is on Saturn is a place where the winds are flowing the slowest. If you go deep down in the atmosphere, you'll see the same winds as you do up high. It's a place where the energy being released deep down below can make it on up to the upper atmosphere without being sheared apart, and allows storm systems to be organized.
Earth's atmosphere isn't built that way. So, as violent as our storms get, they're nothing compared to the systems on Saturn. Even a run-of-the-mill mega thunderstorm on Saturn would devastate us here.
A Saturn-sized thunderstorm on the Earth would mean a thunderstorm that grows to cover all of North America and presumably has very strong winds and rain. This is something that's unprecedented on the Earth.
Saturn's hyper-violent thunderstorms are proof that our planetary neighbors have weather far more ferocious than ours. But the laws of physics that create Saturn's storms are the same laws that create our own weather. Massive dust storms, unrelenting winds, killer lightning, powerful hurricanes, and searing heat.
Mars, the red planet, fourth rock from the sun. For centuries, we humans have gazed at our neighbor and imagined an alien world. And as human technology advanced and telescopes brought it closer, we began to see signs of life.
As the 20th century began, mainstream credentialed astronomers were looking at Mars, thinking that they saw evidence for a society, a civilization on the red planet.
We Earthlings braced for contact. If there was life on Mars, what form would it take? We set off into space to find out. But as we approached the red planet, we discovered a new mystery.
All the elements needed for life were there, so what happened? Where did everybody go?
Mars is almost Shakespearean, a beguiling world. It's tricking us every way.
So Mars, dead or alive? Some think Mars was home to an ancient civilization.
There was at one time intelligent life on Mars, and they built something.
But the evidence continues to elude us.
If there's life there, we'll find it.
Across the globe, the race is on for the greatest discovery of all. Join skeptics and believers alike as we try to answer the age-old question, is there life on Mars? If you're planning a trip to the planet Mars, here are a few travel tips to help make your journey as comfortable and rewarding as possible. All in all, the expedition will take about 2.5 years, including approximately 12 months aboard your interplanetary spaceship. So make yourself comfortable. Plan your provisions carefully. You'll need to bring plenty of water. At this time, there's no liquid H2O anywhere on the planet's surface. You'll also need an effective spacesuit and a sufficient supply of breathable air. Finally, remember, Mars is about 1.5 times further from the sun than Earth, which makes this a cold world. The temperature can drop to a chilly minus 130 degrees Fahrenheit. So dress warmly. These technical issues aside, Mars has a lot to offer. It is home to the largest known volcano in our solar system, a magnificent Grand Canyon, and breathtaking deserts. For those of you interested in culture, a visit to the notorious Face is a must. We know you have a choice, so thank you for choosing the planet Mars. All in all, without ever setting foot on Mars, we know a lot about this distant world. But what we don't know is, what about life? When the first astronauts arrive on Mars, who or what will they find? Will aliens be there to greet us? Or is no one there at all? Inquiring minds want to know, is there life on Mars? It's a big question, and a fundamental one, because really, it's synonymous with the question of, are we alone in the universe?
If we go to Mars and find evidence that there was life on Mars or is life on Mars, then we'd be able to say that in our own solar system, life appeared twice. I think that would be convincing evidence that the universe is full of life.
Discovering life on Mars could also reveal a lot about our own existence.
We have one kind of life adapted to one planet, even with all of its diversity. So looking at the way other planets may have given rise to a phenomenon that we would recognize as life can enable us to understand our own kind of life in a deep and fundamental way.
The stakes are high in the game of life, and Mars may hold the key.
If we're going to find proof of life on Mars, we're going to have to go to Mars to get it.
But getting to Mars isn't exactly easy. The Apollo astronauts took about 2 days to get to the moon. A journey to Mars one way is roughly 7 months. Mars takes about twice as long to orbit the sun as Earth. So a space mission has to plan departure when the two planets are close. The challenge of bringing a mission back is incalculable in complexity. Just one of the reasons no manned mission has ever been attempted. But that's exactly what Dr. Robert Zubrin of the Mars Society wants to do. Bob Zubrin, an astronautical engineer with 15 years of experience in the space industry, has been planning a trip to Mars for the last 2 decades, and he's come up with a novel way to do it.
If we want to go to Mars, we need to travel light, live off the land.
What makes a Mars mission so prohibitively expensive is the amount of mass, mostly rocket propellant, you have to send there and back. Instead, Dr. Zubrin came up with the following plan. Take supplies enough to get there, then make what you need on the planet.
There's 3 things we want to make on Mars. First, most importantly, propellant. After that, water. And third, oxygen. We can make all 3 with this machine.
Here's how the machine works.
The Martian atmosphere is 95% carbon dioxide gas. We pump that into the reactor. We mix that with a little bit of hydrogen. You can make that reaction produce either methane or carbon monoxide or any mixture of the two. And water.
The methane and carbon monoxide mixtures can be used as rocket propellants for the return trip to Earth.
The water, we could keep the water and drink it, or we could electrolyze it into hydrogen and oxygen. The oxygen that comes off, we could use as breathing oxygen, we could use as rocket-propelled oxygen. That's how the machine works. It makes your fuel, it makes your oxygen, it makes your water.
And leaves enough room on your spaceship for food. All in all, it looks simple enough, and it's not just theory. Working with simulated Martian air, Zubrin has spent years testing and refining the technology.
This is a subscale methane, carbon monoxide, oxygen rocket engine. It all works. It works great. These are great propellants. We start them right up with a spark plug time after time.
In a way, Zubrin has done all this to make a point. Current thinking is that it is too expensive and dangerous to send a manned mission to Mars. Instead, the international space community has deployed a range of unmanned robotic explorers on and around the planet. But Zubrin points out using robots to do field research leaves a lot to be desired.
Okay, we can send robots to Mars. And I support sending robots to Mars. I think we ought to send a lot more robots to Mars. Okay, robots can make all kinds of discoveries. They can give us all kinds of data. They can image the surface of the planet and possibly identify interesting targets for exploration. But they won't tell us the answers that we need to know. They won't tell us if there's life on Mars.
So does Zubrin expect to find life on the red planet?
I think that a naturalistic view of the universe would suggest that the Earth is not special, and that if life can evolve here, it could evolve elsewhere where environmental conditions are similar. And if there's life there, we'll find it.
But perhaps there's an easier way to find out. The answer could already be here on Earth. Every year, hundreds, maybe thousands of aliens come to our planet. Most arrive quietly and go unnoticed. Others enter the atmosphere in a blaze of glory. These aliens are meteorites. For centuries, these rocks from the sky were treated as curiosities, often ending up in local museums or private collections. But the information meteorites contain is so valuable that today, the scientific community sends out search parties to gather them. Although meteorites fall randomly all over the Earth, one of the most popular hunting grounds is Antarctica. Every year, scores of scientists take their lives in their hands and head to the frozen continent. The teams conduct a systematic grid search of the icy landscape, looking for telltale dark shapes against the blue-white of the ice. It was on an expedition such as this that a meteorite was found that would shake the scientific community to the core. The team sent it to a special facility at the Johnson Space Center in Houston, because this is where NASA keeps the aliens. 84001, or the Allen Hills meteorite. The strange green rock was kept under strict quarantine. It was processed, examined, and rigorously interrogated for information about its home world. It took 10 years, but investigators finally got the truth. This rock was from Mars, and it had a secret to tell.
Today, Rock 84001 speaks to us across all those billions of years and millions of miles. It speaks of the possibility of life.
So what was it the rock told us? We'll come back to that a little later. But perhaps the best evidence of life on Mars is not hidden deep in an alien rock. There are some who believe a vital clue is staring us right in the face. Richard Hoagland has dedicated his life to examining imagery transmitted to Earth from various Mars orbiters. Surveillance systems that have circled the red planet for over 30 years now. In the first pictures that the 1976 Viking orbiters sent back from the planet's surface, Hoagland saw something that blew his mind.
I looked at this and it was like, oh my God. This thing had symmetry, it had proportion, it looked like a statue.
Hoagland is referring to this remarkable image. A face-like structure the size of multiple city blocks. And Hoagland thought he saw more. Other structures surrounding the icon, eroded by time. To him, it looked like the ruins of a monumental city.
It looked eerily like an aerial photograph taken flying over Giza, looking down at the pyramids on the Giza Plateau. It looked like a ceremonial complex built by somebody with a huge sphinx-like creature staring up into space from the sands of Mars at the telescope orbiting 1,000 miles overhead. Somebody was down there, and they cared enough to leave the very best.
Needless to say, Hoagland's theory raises more than a few eyebrows. But did life on Mars ever exist? Was there once an ancient civilization of alien life forms? And if so, where did they go? Believe it or not, the idea that Mars was occupied by a race of intelligent extraterrestrials was not the creation of science fiction, but science fact. In the early days of humankind, Mars burned faintly red in the night sky, leading some to equate it with a mighty god, naturally, the god of war. But then astrologers using a new contraption called the telescope determined that those lights in the sky might be planets, much like ours. This meant there might be other civilizations, other life forms out there. And Mars was about to become the star attraction. Thanks to Italian astronomer Giovanni Schiaparelli. In 1877, Schiaparelli trained his telescope on the Martian surface and observed the existence of canali. By this, he meant natural channels. But due to an unfortunate translation, these channels became canals, which implied a man-made phenomenon. To fully understand the impact of this, consider that only a few years earlier, human engineers had completed the awe-inspiring Suez Canal. It defied nature and geography by linking the Mediterranean and Red Seas. It was considered the latest wonder of the modern world. Whether or not Schiaparelli believed the canals to be made or natural, the word itself sparked the public imagination. If there were canals on Mars big enough to see from Earth, really intelligent beings must have built them. The rumor was dramatically compounded by an American astronomer named Percival Lowell. Lowell was a highly respected man of good society who had a profound love of astronomy. He developed a fascination with the canals of Mars and sat up through the nights observing the red planet. And what Lowell thought he saw in the wee hours was a dying world crisscrossed by constructed waterways. Perhaps, he wrote, creatures short on water have built an irrigation system that circled the planet. By the turn of the 20th century, the idea that Mars was occupied had hit the mainstream media. New York Times headline, 1911. Martians build 2 immense canals in 2 years. Martian civilization was usually perceived as being ahead of us in evolution. And each Earthbound nation projected onto Martian society the diverse vision and fears of its own future. In this 1924 movie from Russia, Mars is portrayed as going through a proletariat revolution and ending up successfully communist. But many thought that Mars was dying, and some said it was only a matter of time before Martians tried to contact us. And so, some thought, they did. Through another new technology.
This is Seth Shostak. Go ahead, caller.
Radio. Astronomer Seth Shostak takes up the story.
It goes right back to those early radio pioneers, and none so directly as to Nikola Tesla.
One of the most brilliant electrical engineers of all time, Nikola Tesla, was the first to claim someone from beyond this planet was trying to get our attention. In 1899, Tesla was experimenting with an electric invention that essentially acted as a large antenna when he noted something strange. Repetitive signals which were substantially different from the signals he had noted from storms and earth noise.
And it's only natural to imagine that he would ascribe this to some sort of intelligent beings, because as far as Tesla knew, only transmitters could make radio sounds. So he naturally assumed that if he heard something, somebody was broadcasting it.
In fact, Tesla was probably mistaken, as Shostak often gets to explain on his weekly SETI radio show.
Well, we don't know for sure what Tesla heard, but most likely it was something that we call whistlers. These are just distant thunderstorms, lightning discharges that produce natural radio waves that get distorted by the atmosphere as they propagate around the Earth and make a sound that kind of sounds like a whistle.
Modern science may have an explanation, but in a way, Tesla was ahead of his time. The idea that you could send signals from one planet to another made sense and inspired subsequent radio enthusiasts to listen for signals from outer space.
A guy by the name of David Todd realized that in 1924, there was a real opportunity to listen for the Martians. And the reason was that in 1924, you once again have one of those circumstances where Mars and the Earth got close to one another. So he organized an effort to get people to stop transmitting for 5 minutes every couple of hours so that people with the right equipment could actually listen, and this included the military, to listen for signals that might be coming from Mars or some other planet.
But whatever the message might have been, it seems we humans didn't get it. At which point, the Martians turned nasty.
Ladies and gentlemen, we interrupt our program of dance music to bring you a special bulletin from the Intercontinental Radio News.
In 1938, Mars attacked. Turns out it was apocryphal, an imaginative radio play based on the H.G. Wells book, War of the Worlds. But many believed it and thought Earth was under imminent threat from aliens.
Now, mind you, it wasn't so unreasonable. I mean, there were places that really were being invaded at the end of the 1930s, after all. So the mindset of the public was kind of attuned to the idea of hostile forces coming in and taking over.
And sure enough, they came. Martians, great and small, came out of the skies and landed in our movie theaters. Sometimes they looked like giant insects. Mostly they seemed suspiciously human-like, and they came in a bewildering variety of shapes and sizes. They had laser guns, evaporators, death rays, and deadly kisses. They wanted gold, weapons, earth women, and human blood. One thing's for sure, they were very rarely friendly. Next thing you know, real flying saucers were being reported from San Fran to Timbuktu, and the phenomenon of alien abductions was born. The world, it seemed, had gone crazy for extraterrestrials. For all its downside, the popular imagination paved the way for mankind to make that giant leap. In 8 years, the U.S. built a transport system and became a spacefaring people. Perhaps we were determined to bring democracy to the communists on Mars. In fact, we only got as far as the moon. And while there were no aliens up there, you might argue that if we could make the trip, then extraterrestrial life, capable of interplanetary flight, was at least a possibility. So what about Mars? As our technology got better, we sent a robotic scout to the Red Planet. The landing was a success. The robot touched down, turned on the camera, and we finally got a good look at Mars. It wasn't what we expected.
How disappointing after centuries of assumption that Mars was inhabited, that it had cities, it had canals, and the reality was that it was just this terrible, awful, dead-looking place.
Ladies and gentlemen, we regret to inform you, Mars is dead. Or is it? Mars may be unoccupied now, but if we're to believe Richard Hoagland, the Red Planet once hosted a magnificent civilization. Hoagland is the principal investigator of the Enterprise mission, a loose collection of scientists, researchers, and Mars enthusiasts. They've spent years trying to prove this extraordinary theory. For Hoagland, it boils down to this.
If I had one catchphrase to describe the whole problem of convincing
99.8% of the mass in the solar system, and it weighs 300,000 times more than the Earth. It is made up almost entirely of a superheated form of electrified and magnetized gas called plasma. The sun packs enough gravitational pull to keep the planets from spinning off into space. And as Copernicus first suggested, it rules the center of our solar system with a gravitational iron fist.
Copernicus's model, in which he placed the sun in the middle of the solar system with all the planets going around it, instead of everything going around the Earth, was a giant paradigm shift. It meant that the sun is the most important thing in the solar system. It meant that we really should understand the sun.
Our sun, like all other stars in the universe, is made from the dust of stars that lived and died over billions of years, going all the way back to the Big Bang.
So our sun and our solar system is really the debris from many generations of stars.
The sun we see every day is the solar system's source of power. Deep in the center of our star, its core is superheated to 27 million degrees Fahrenheit and is the engine that drives it all.
Inside the sun's core, the process of fusion is occurring, and that fusion process is giving off light and particles.
Every second the sun shines, it releases the same amount of energy as 1 million H-bombs. The sun's light is made of particles called photons. born in the core, then propelled by convection currents through the radiative and convective zones of the sun. Eventually, they reach the volatile outer layers of our nearest star.
The sun's outer parts consist of three regions. There's the photosphere.